still working on graphing linear inequalities, but these are going to be a little different because when we graph them, and notice that I've got 3 of them to graph here, we're going to find that we get some shapes. In this first one, a triangle, and we're actually going to be looking for some more information than just graphing the region. So to get started with this, I do have to graph these inequalities, which means I need to graph the boundary lines, and I am going to choose to put them into slope-intercept form. You wouldn't have to. You could graph them with the x and y intercepts, but I'm going to actually change these. So for the first one, I'd have negative y greater than or equal to negative 2x minus 1 if I subtract 2x. Now I'm going to multiply both sides of the equation by a negative 1, so I get y less than or equal to, because you got to flip the inequality, 2x plus 1. So that's going to be my first inequality that I'm going to be graphing. This second one, and I think I'll switch colors, we're going to end up with y is less than or equal to negative x plus 4, because I just have to subtract x from both sides. And for the third one, I'll have 4y greater than or equal to negative x plus 4. Then I have to divide everything by 4, so I get y greater than or equal to negative 1/4 x plus 4 divided by 4 is 1. So these are my lines I'm going to graph, the boundary lines. So we need to graph 2x, y equals 2x plus 1. So my y-intercept, and then my slope is 2, so up 2 over 1. And notice that all of them are solid lines. So I'm going to actually grab my line tool here and graph that. Okay, so this is what my line would look like. And we want to be below the line, so I'm going to use that, which is one of the reasons why I wanted to put them in slope-intercept form, because then I'm going to be below the line. So I know I'm going to shade that side of the line. So now let's do the next one. My y-intercept is 4, and I have a slope of negative 1, so down 1 over 1. Making sure that your line is going down from left to right. I'm going to go ahead and graph that. And this one is less than, so this tells me I'm going to shade below that. So it's going to put me on this side of the line. And for the last one, my y-intercept is 1. I have a slope of negative 1/4, so down 1 over 4. And when I graph that line, I get this region. And I want to be above this line. So now you can see the region that I'm trying to shade. It's actually this region in here. Here's my triangle. So that means if I were just strictly looking for the solution would be my highlighted region inside that triangle. But I'm not asked just to do that. I'm asked to find the coordinates of the vertices. Well, these are really easy to see because I get 4, 0, and this would be 0, 1, and this would be 1, 3. So the vertices are just the where the lines intersect. So the corners of my triangle, and those would be the vertices, and now I have finished the problem. So here's one for you to try. So go ahead and graph that, and then you can, so pause the video, graph it, you can check your answer. All right, so what you should have gotten, here are my lines, so you can check the work in having it in slope-intercept form. Because this is greater than or equal to, it's going to be above, less than or equal to below, less than or equal to below, so I make sure I'm thinking about have the right region. You could shade in that region. We get this triangle here. But remember, the question was to find the vertices of the triangle. So we can see this one is negative 1, 1. I didn't put my scale, and I probably should have. This corner here is 0, 3. And then we need this spot right here, and it looks to be 5, -2. Now, what if you can't tell where two lines cross? What if you're not really sure? Remember how you can find them. So like if I wanted to know where my red line crosses my blue line, I could take these two that I've already solved for y now, and I could take -1/2 x plus a half equals -x plus 3. So if I set this blue equal to the red and I solve it algebraically, I can find where the two lines cross. So if I solve this equation, I should get 5 for x, and then I could plug it back in to get the -2 for the y value. So remember, that would still be an option, and I would have to do that if they didn't cross on these nice little grid points like this problem does. Well, this one looks different. It is a system of inequalities, but notice they're not lines. The first one is, but my second one is an absolute value inequality. So we're going to solve this system of inequalities. We're not finding the corners or anything of vertices on this. So for the first one, I'm going to graph this one in blue. It's a line. It's going to be solid. I'm going to have to shade. So I'm going to count by ones here. So my y-intercept is 1. My slope, so I'm going to go down 1 over 1, making sure it's negative, a negative slope. And then I'm going to go ahead and graph this. Whoops. Should have got the line tool. And we're going to shade below the line. So this is telling me below. So I'd be shading on this side. This inequality, the absolute value inequality, remember, as soon as you see this, you should think V-shaped. So my vertex, we go to the left one, so it's -1, -3. So to the left one, down 3 is my vertex. This is like having a 1 here. That's my steepness, kind of like my slope, but remember we have to make a V. So up 1 and over 1 in both directions, making this V shape. It is strictly greater than, so it's dashed. And I need to be above that, so go to your vertex and shade above. So I'd be in this region. So I'm below the blue line, above the red line, so then my shaded region is going to be this here. And that would be my solution. Okay, kind of like what we did the first part of the this video, part A, where we just had to shade the region, and this would be my solution region, which means anything in that highlighted region makes both inequalities true at the same time. And here again, we have a different type of inequality in a different set of directions. This time, I'm asking you to find the area of the region defined by the system of inequalities. So these are both the second, well, they're all lines, but remember this is just going to be a vertical line because it's just x equals something, but my boundary line would be x equals -3. So if I count by ones, x equals -3, and notice they're all solid lines. So here would be my first line. And I want to shade where the x values are greater. Well, the x values are greater when you move to the right, so I'm going to be shading on the right side of that line. Then for the next one, and it's okay if you prefer, you could do this one with the x and y intercept methods, except then you have to test a point to decide which part to shade, or you could switch this to x is less than or equal to, if I subtract x, that's pretty easy to do. So then my y-intercept is 8, and I'm going to go down 1 over 1. So I'm definitely going to get this. Now I'm guessing, I'm going to extend this because I can see already, I'm probably going to have to extend this too. So I can see where they cross. Should have counted by 2s. And the last one, I'm going to switch this to y is greater than, if I add x to both sides, then I do this. I don't have to worry about flipping the inequality unless I multiply or divide by a negative, remember. So my y-intercept is -2 and my slope is 1. So this green line, whoops, is going to be here. And one more thing, I'll just extend this red line down to here. Okay, so if I needed my vertices, you can see what they are. I mean, I didn't ask really for them on this one, but we can see that the vertices 5, 3 would be this corner here, and -3, 8 would be up here, and -3, -5 would be here if I needed the vertices. I probably should have checked. Here I wanted to be below the line. Oops. And here I wanted to be above the line. So you can see I am in that triangular region. But the question I asked was find the area. So you have to think about, how do you find the area of a triangle? Well, to find the area of a triangle, we're going to take base times height and divide by 2. Or you may have thought of it or learned it as 1/2 the base times the height. So we need a height here. Well, pretty conveniently, if I'm going to do the height this way. Remember, the height has to form a right angle with the base. So I'm treating this side that's in red as the base, and this that I've drawn in as the height here. So I can count that. So we have a height of 8, it looks like. Or you can actually take the x values, 5 minus a -3 is 8. And then the length of the red, it's going to be 8 minus -5. So we get a total of 13. And to find the area, it's 1/2 the base times the height. And you can actually do a little canceling here. So we get 52, and I don't have units given, so I'm just going to say square units. So sometimes you have to take the strategies of graphing the inequalities and you might have to do something else, like find the vertices, or in this case, we had to find the area. So we got to just kind of pay attention to the type of question that you are asked. So that takes care of our examples and our notes from sections 3-2. This is part B, and you'll have a homework assignment that will help you learn this.